Welcome back. Now we know how to print strings, we know how to draw debug spheres, and we know how to draw debug arrows. And we've seen that the debug sphere and debug arrow utility functions take in data of the vector type. Now we'll be talking about vectors in a lot more detail very soon, but before we get into that, we're going to use one more utility that takes in something different than a vector. Let's do that. I'm going to go ahead and remove these nodes. Just highlight them and delete them for now. And I'm going to right click and search for draw debug coordinate system. Let's get that function. Now notice that this function has a number of inputs. One of them is a vector. Axis loc. Loc is short for location. So this is going to be the location where we would like to draw this coordinate system. And we're just going to draw one of these and see what it looks like. Now notice there isn't a color, but there is a duration. We're going to set that to 60 seconds so it doesn't go away. And we're going to change the scale to 100, and we'll see why shortly. And we're going to press play. And there it is right there at the origin. That's because that axis location was 0, 0, 0. Now, it's really hard to see. Those lines are really, really thin. So we can take the thickness and bring that up. Let's put it up to about 3 and press play and take a look. And there it is. That's the coordinate system. It's showing 3 arrows, X, Y, and Z. However, this coordinate system can be rotated. Let's hit escape and go back and take a look at the second input for this node. It's called axis rot. Rot is short for rotation. Now, what I'd like to do is draw this debug coordinate system at the drone's location and the drone's rotation. Now, we know how to get the drone's location, right? We just right click and type get actor location. And this gives us a vector. We can pass that in for the location. If get actor location gets us the actor location, then what would you suppose the function would be called that gets us the actor rotation? Well, if you guessed get actor rotation, you'd be right. Get actor rotation will get us the rotation. And look at the color of the return value. It's blue, just like this one. Hovering over it, we see its data type is rotator. So Unreal Engine has vectors, and it also has rotators, which are more designed for rotational information. Let's drag that in for axis rot, and let's just press play to see what happens. Well, look at this. We have our coordinate system, and it's rotated such that it fits our actor's individual rotation. Our actor is not aligned with world rotation, it's tilted in its own direction. And we see its X, Y, and Z directions respectively. Now, one very important thing that you need to know about Unreal Engine is that an object considers its own X direction to be forward, which means that our mesh is pointing in the wrong direction. Let's go back out to Basic Map and let's select our drone actor. Now, when we select an object in our level, we get this gizmo that shows us the X, Y, and Z directions, right? Well, these are the X, Y, and Z directions for the world. We call this world space. This individual actor has its own local rotation. And we can see that by going up to this icon here. It looks like a world. If we click on it, it changes now. And we've just cycled to local space, which means that the gizmo is now pointed in this actor's local directions. I'm going to click that icon to go back to world space, and I want you to pay close attention to the gizmo on the drone. Let's go back to world space. Notice it's pointed that way, which, by the way, corresponds to the little coordinate system at the bottom left of the viewport there. These red vectors coincide, the green vectors coincide, and the blue vectors coincide. But if we switch to local space, we now see that this is the drone actor's forward vector. This is the drone actor's forward direction. And the drone's mesh really should be pointed in its own forward direction. It shouldn't be pointed to the right. Why? Because if we script out some functionality in blueprints and tell this actor to move forward, well, then it's going to move in its forward direction and it's going to look like it's going sideways like a crab. And our drones are not crabs. So there are multiple ways to fix this. One would be to export this mesh and open it up in a mesh creation software and rotate it so that it's pointed in the correct direction. Another option is to go back and add a scene component and use that as the root, just like it was before we replaced the root with the drone mesh. In other words, we can click Add, we can choose Scene to add a scene component, and we can set that scene component to be the root. We do that by clicking and dragging it onto the current root, which is the drone mesh, and if we release, it's going to swap the two components. Now the scene is the root, and the drone mesh is attached to the root. And now we can rotate that drone mesh so that it's facing this actor's forward direction. I'm going to press E to go to rotate mode. I have snapping enabled, so I can rotate by exactly 90 degrees. And now the mesh itself is pointed in the X direction of the actor. The gizmo shows the directions of the static mesh, but if I select the scene component, well, that gizmo goes away. And we can see with the coordinate system at the bottom left in our viewport that our mesh is facing the actor's X direction. And if we go back to basic map, now we see that this is what it should look like. And that's, of course, because we have local space enabled. If we go back to global space, we can move the drone in the global directions. But if we go to local space, now we can move the drone in its own local directions. And we see that it's facing its own forward direction. And if I press E to get the rotation gizmo and I rotate that mesh to face this way, and I press W to get that translation gizmo, we see that now its forward direction is facing that way. So now what happens if we take a look at our debug coordinate system? Well, let's press play, and we can see that now the drone is facing its own forward direction. So in Unreal Engine, the X direction for an actor is its forward direction. The Y direction is its right direction, and the Z direction is its up direction. And it's important that the mesh on our drone reflects that. It should face the positive X direction. So now we understand that every actor has its own local direction, and we can always see that by swapping between world and local space with this icon at the top here. And we now have the ability to draw a debug coordinate system, and this is very, very useful, as this debug utility is what allowed us to even discover in the first place that our drone's mesh wasn't even facing the correct direction. Now we know it is. So now that we have a little bit of experience with vectors, and now we also have experience with rotators, it's time to get some deeper theoretical knowledge on these types and their mathematical and geometrical significance when it comes to game development. So the videos to come are going to give you a little bit of a math refresher on vectors. And if you already know this stuff, maybe you learned this in school or in college, you could skip those lectures, but I recommend watching all of them to get a bit of a refresher, just so you're up to speed on vector operations, as we'll be using these throughout this course, and you'll be using them throughout your career as a game developer as well. So excellent job, and I'll see you in the next video.